Hello, my name is Giulia Guizzardi, and I'm on the community team at the DFINITY Foundation. Today, we have our first workshop, and the topic is Introduction to Building on the Internet Computer, Motoko and Rust. Here with me, there are two speakers that are joining today. Carsten Jacobsen, who is a Senior Developer Relation Engineer at DFINITY, and Hamish, who is a software engineer building OpenChat. They are going to kick things off with the workshop, and I will be monitoring the chat and checking in if there are any questions or comments. We will save the Q&A in the end, and to help also our speaker to be in the flow and not to disrupted too much. But if you have anything that is urgent and you want to bring it up, I can also interrupt them a little bit and ask them poignant questions. So without further ado, I'm going to hand it off to Carsten. So you are feel free to take it away.
Thank you. Yeah, welcome to this this first session of workshops where we are going through the Internet Computer, how to build on it, and this is the introduction. So even if you're new to the Internet Computer, this is a great starting point. Let's see. You'll see in this presentation, in this workshop, you'll see Hamish and I, we will be doing some live coding, and we'll be using Macs, but you can use any platform you wish. You can use Macs, you can use Windows, you can use Linux. And for Windows users, we recommend using WSL2. And then you can run the same commands, you can run the same SDK as we're running here in this session. So what is the Internet Computer? Very high level, it's a blockchain that enables developers to build and deploy secure, autonomous, unstoppable, and tamper-proof software. And we run it at web speed, capable of scaling without limits. What this means is, or I would say one of the things that I like about the Internet Computer is that you can run everything on chain. So you run the entire dApp, you run your front end, you run your back end, everything is running on the chain. That's a feature of the Internet Computer I appreciate a lot. The smart contracts can contain both the front end and the back end, as I said, and the dependencies of the dApp. We are going to present two programming languages today in our workshop. I'm going to do some coding in Motogo, and Hamish is going to show how to use Rust. But anything that can be compiled into WebAssembly can actually run on the Internet Computer. Some of the smart contract traits of the Internet Computer is that they're composable, which means that they can talk to each other. You can use tokenization to use or to trade digital tokens. It's cost effective. It's a lot cheaper to run your dApps on the Internet Computer than many comparable solutions. And we provide higher throughput and scalability. Yeah, let's go to the next here. This shows the architecture, the high-level architecture of the Internet Computer. At the bottom, we have data centers that run nodes, which are split into subnets. And on these subnets, we run the canisters. Canisters is a concept we use to deploy the smart contracts. We're going more into details with that as we go through the code. So the tool we're going to use is the DFINITY Canister SDK, also called Dfx. And the way we use Dfx is that we can use Dfx to create a new project. We can write some canister code, and then we can use Dfx to deploy either locally or to the mainnet. Typically, we use the local deployment when we develop the code and test it, and then finally when we have a dApp that we wanted to publish, then we can use Dfx, our SDK, to publish it to the mainnet. So this is how you install the SDK on your local system. You run this command, and all of this is described in our documentation at smartcontracts.org. And after running this install script, you can verify that you have DFX installed by running dfx version, and you can see that you're running the latest version, in this case 9.2. I want to spend a little bit of time going through Motogo because for a lot of developers, Motogo is new, and Motogo is the programming language we have developed in-house to write smart contracts and to run dapps or to develop dapps that run on the internet computer. And if we go through some of the high-level concepts, we are using the actor model, which is a way to encapsulate the code with its state, and these actor models can interact with each other. So it's a way to organize our code in canisters and to expose them to other canisters. So the actor model allows us to keep the code in the canister contained with its state and everything, and dependencies and everything. We use asynchronous functions, and we use futures, which is very similar to promises. So with all the functions you make, you can call them as asynchronous functions. Something that's different in the way we work on the internet computer and in the canisters is that we store data in memory. So we don't save data to a disk, or typically not in a database. We store it in memory, and the actors can store this state, and there are methods to restore this and keep it persistent. So when you do an upgrade, that you don't overwrite. We'll go through that in our code samples. We are auto-generating an IDL file, which means that the functions in the actors are exposed. So you can either expose them to an external website, or you can to an external service, or to another canister. But this is really what this session is about. It's building a DApp, and let's get started with that. The DApp I'm going to build here is very simple. It's just a counter. We are going to use the default DApp you get when you run the dfx new command. And instead of using the hello world that the DApp is usually usually features, we're going to turn it into a counter. And this functionality is very simple. You click a button, and then the counter counts 1 up. So what we're going to do in this little project is that I'm going to show you how to create a new DApp using our SDK. I am going to use the default template that it comes with, and then modify it so we get the counter functionality that we want. I want to show you how to test both the front end and the back end, and use the candid interface to show you how the interface between the front end and the back end, how we can test that in a very easy way as well. And yeah, then when I'm done with my part in Motogo, then we'll go to Hamish, and he'll do the same in Rust. Okay, so let me start my code editor. Okay, so what I did here, I start an empty code editor. I have nothing, and then I just assume that that dfx is installed. So what I'm going to do now is to install the default application. So let's try that, dfx new, and let's call this hack. This is a hackathon. This should only take a few moments. Okay, so this completed, and we have created a folder here now. I want to spend a little bit of time going through what we see here and what was generated by Dfx. If you look at this, you see a folder called source, and in that we have two folders. Then we have one called hack, and we have one called hack assets. The folder called hack is where we have our Motogo code. And if we look at, let's see, if we look at the file, it's very simple. There's only one function here because it is the default app. It's the hello world application. There's only one functionality, and that is to take an input from the front end and then append hello to it and return it. We can actually, we can actually load it up now. I'll do that later. And if we go into the assets folder, we see that this is where we have our HTML. This is where we have our front end, and we have here the logic that connects to the backend. We see here we import the backend functionality, and then we have just plain JavaScript that registers when we click a button, take the information from an input box, and then we submit it to the greet function we have in the backend. In the assets here, in the assets folder, we have just the logo and other things we need. Let's try and look at, let's see. Let's try to look at it. I have browser. So if I want to look at this now, I have to start, let's start the backend. So say Dfx and start. Oh, I need to go into the right directory. In this directory, the reason it gave me an error was it was looking for a file to show how to set up the local environment, and the file it was looking for was this dfx.json. This file contains information about the canisters we want to deploy. We have the backend is in one canister, and we have the front end in another canister. And then in this file, we have some description of what version of Dfx we're running and where we are deploying it to. So, so let's get the local environment started. We do that with Dfx start. And now the replicas are up and running, and it's listening on the local host. Let's start up another one here. Okay, so what we can do now is we can actually go and look at, let's start the application by deploying it. So when you deploy it locally, it will set up everything you need. It will set up a wallet canister that contains a lot of cycles that you will never run out of when you run it locally. Every time you deploy a canister, there is a charge, and it's just charging it to the wallet canister that comes with the local replica, and it never runs out. Okay, so now the canisters are deployed, so we can actually go and look at the website. So let's try to do that. I need to figure out where this is living. So I go to my Dfx, and I have my local deployment here, and I want to look at the canisters. If I look at the canister IDs, the JSON, I'll get the list of the canisters that Dfx installed for me. I have a candid UI. We'll get back to that one. It's the interface between the front end and the back end. We have a local one for the back end, and we have one for the front end. Since I want to serve this in a web browser, I want to look at the front end. So let's copy this one, and I'll pull this in. Let's see. Need to. Let's take a look at this. So this is actually the dapp that's running on my local system right now. This is the front end. As you see, if we go back to the code, under the assets, this is actually the HTML we're seeing here right now with the logo we have in our assets folder right here. So right now this is running on our local system. We could deploy this. If we deployed this on the main net, it will look exactly the same. It will work the same. And this is the default application it comes with when you run the Dfx new. Let's just try it for fun. Let's see. Just write something. So what it does now is it takes the, if we go back to the index here, it gets the value we put into the input box, and then it sends it to the greet function in the backend. Then it appends it to a hello and returns it. And when we get it back here, we put it back out on the screen again. So we could deploy this on the main net and it would work just the same. But we want to try to do something more custom here for this workshop. So we're going to take this and we're going to modify it a little bit and turn it into our counter instead. So if I just get so this is the function we have right now. Let's see there. And since we're going to build a counter, we don't really need this anymore. So I'll keep the actor because that's the same, but I will start to add a couple of functions here. First, I'm going to initiate a counter variable. And I want that to be a number. And let's just initialize this with a value of 0. So this is the counter that we keep track of. So when someone pushes the button in the front end, we want this to count up, and we want to be able to pull that value if someone news come onto the screen and they want to get the latest value. So we initialize this here. Okay, and then we create a public function which sorry, a function called count, and we don't need to take any variables. We make it async, and what we want to do is when we call the counter, we want it to count 1 up and then return the new value. So let's return the value as a number, and then this is very simple. Okay, so what we have now is we have a function we can call that has the feature that it will count the counter 1 up and then return the counter. Then we would like to be able to get the counter. So let's create a function that will retrieve this value for us. So The screen is a bit slow. And we can here tell Motogo that this is a query function. So this is not modifying any data. And let's call this get count. And we also return that as a number. And this is actually this is just returning the counter. Okay, so what we have now is we have a counter that we can invoke from the front end, and then we have a get counter that will take the current value and return it to the front end. So let's just say this is what we need for the backend, and we'll save it. So I just mentioned briefly that we have the candid interface, and I think this is a good time to give a little bit of introduction to that. So candid is the interface that we define that goes between the front end and the back end, and we actually have a user interface that shows that exposes the functions and actually makes it possible to test it. So let's try that out. Let's redeploy this. Oh, let's see. But because we're changing the Motogo code and the functions that are exposed, we have to confirm that we want to do that. Okay, so now it's deployed to our local replica. If you see up here, there's a new folder called declarations, and this is actually where we see the candid interface. And if we look here, it has created two endpoints, one count and one get count. It takes no parameters in either of them, and they're returning a number. And this is the one we want to test in the UI. So if we go back up here where we look at the canister IDs that Dfx created, we have the UI at this address. So let's try that instead. Oh, and I need to specify my backend, which is this one. So this is the candid interface that is automatically generated, where we have the count and the get count. Let's try to run the get count. Right now, the counter has the value 0, so it returns 0. Let's try to count one up. This call took a little bit longer, and that's because we're actually updating data. So now it returned 1 because it counted one up, and we can count one more up. And we can call the get count and get the same value. So Candid is a really, the UI is really a convenient way to test that your backend functionality is working like intended, and it comes automatically. It's not something you need to build or create specifically. It's a part of the deployment process that this is built. Okay. So now we have the backend functionality that we want. We have the counter and we have the get count. So now we need to make the changes in the front end because we don't need the hello world functionality anymore. So let's go and clean up this file. We still want to import the candidate description. So this one we keep, and we still want to listen to the button. Let's see. Okay, so let's take a look at the index file here. This is we need just to make a few adjustments. Let's see. So this one, instead of calling greeting, we just call it counter. But otherwise, and let's change this one. Let's create. And let's call it click me. Okay, so now we have just a button on the screen. We have the logo, we have a button on the screen, and then we have the output section where we can put the results. We don't really need an input field. We just need the button in this case. Okay, so next step is to go and make the changes in the index file. And let's see. Let's just deleting what we have here. So what we want to do first, instead of this one starts out blank, what we want to do here is first we want to get the count. So initially, when you go into this website, you want to see the initial count, which is 0. So let's make that change and see when the page is loaded, and then get the current count. So and add an event listener. Okay, so here we will call the get count function. We can wait for it to return because we are running the functions in the backend asynchronously. Then we want to output it. Okay. So because the backend functions are exposed through the candid, we can call it. We can call the get counter here very easily, and then we get the value and we show it on the screen. This should actually work right now, so we can try to redeploy it. Okay. And if we reload this page, that is an error here. Let's see. Redeploy. I made a mistake here. It's called get count. That's why it was not coming. Okay, so here we see the counter is getting the count, and right now there's nothing hooked up to the button, but that's the next step. Let's do this part as well. So let's see. Oh, actually. Listener. So actually, we don't need to look at what the function returned, but since we want to update the number of the screen, we will use the return value. Okay, and then okay, so when someone clicks the button, the event listener fires, and we will get the current count value, and then we will update the number on the screen. So let's try to redeploy this. Back here. And we can see that the counter is updated. And we click the button. So just to sum up, what we did here, we took the standard default application that you get when you create a new project using DFX. We modified the backend code. We deleted the greeting function that it came with, and we created a new set of functions. That one is the counter that will take a value and count it one up, and one that will return the counter. And then the counter status is saved in a variable, and this is all contained by the actor. So the actor is holding both the functionality of the smart contract and is also holding the state of it. And this is deployed in a canister that is deployed on our local replica. So this covers the back end, the front end, and we looked at how the candidate interface can be used, also how it can be evaluated using the candidate UI. All the canister addresses that are created by DFX is listed in the canister IDs. If we would take this application and push it to the mainnet, there would be a new canister IDs file created that will show the actual containers, canisters that would be it would deploy to. And we can also specify which canisters we want. So if we already have set up canisters, then we can choose which canisters we want to deploy the application to. Okay. And yeah, this was my little introduction to how to create a counter in Motogo. Hamish is going to show how to do the same, just in Rust. So I will stop my share screen.
Thank you so much, Carsten, for everything. It was a really nice run through. And yeah, Hamish, the floor is yours.
Okay. Can you see my screen?
Yes.
Okay, cool. So I'm
maybe
just
can you zoom a bit? So it could be a little bit bigger.
The text will be bigger when it's in the main window. We'll see.
Perfect.
if it needs to be made bigger, I'll make it bigger again. So yeah, I'm just going to be building the back end, so not what Carsten was doing, which was back end and front end. But yeah, the back end will be written in Rust. When you are creating a new canister, you can decide whether to use Motoko or Rust. You can, in theory, use any language that will compile to WASM, but realistically, you're going to need to make use of the system functionality. And so realistically, you can only really use Motoko and Rust because they have good integration. They have good canister development kits. We've called them CDKs. As more languages have CDKs built for those languages, you'd be able to use them too. But for now, I'd really recommend just using Motoko or Rust. So, okay, so to get started, you do dfx new, and you can call the help function to see what the different options are. So in our case, we need to pass in the project name. We don't care about front end, so we'll specify no front end, and then type, we can put Rust. So let's do dfx new. I'll just call it hack. Hack as well. No front end, and then type is Rust. Have I done that right? We'll see. Oh yeah, and I've installed DFX, the latest version already. So I'm on DFX 0.9.3. Okay, so this will have created a few files for us. In fact, let's get rid of that and get rid of that. Okay, so if we open up librs, which is essentially where we'll do everything, just to make sure it's all set up, let's just do a cargo build. Okay, I need to change into the hack directory and then do a cargo build. So I've already got all of the Rust tooling installed. If you're going to be building your canisters in Rust, you're probably going to want to use something like Visual Studio Code, or I'm using one called Sea Lion, which is one of the JetBrains IDEs, which I find works quite well. Or any IDE you want, really, as long as it's got Rust integration. So when this is finished building, in fact, I can get started while that's still building. So what we want to do is we want to run Dfx locally. So we can say Dfx start. And again, I need to move into the hack directory. So Dfx start. What this does is this runs an instance of the internet computer, but just on your PC. So it's just good for doing local development. So that's running, and that's built, and we can just try it out by doing Dfx Deploy. And what this will do is it will create any of the canisters that are listed in a Dfx JSON. So in this case, it's hack and hack assets. We're not going to care about assets, just this hack one. It starts with just a greet function where you pass in a name and it returns that name to you. But same as what Carsten did, we're going to get rid of that and we're going to build a counter. So we'll build exactly the same functionality as Carsten did, but just in Rust. Yeah, it sometimes takes a minute or so to build your canisters. It will be quicker on subsequent builds because it builds incrementally. So the first build will be slow, but then any other changes we'll make should happen in seconds, the rebuilding. Nearly there. Okay, here we go. So what this has done is it's deployed this hack canister, but it's also created the Candid UI. And Candid UI is essentially just a UI for calling the methods on your canister. So I can pass in here ABC. And if you see this URL, this is running on my PC. And this is the canister that is the request is being sent to. And then this is just a query string that canister can then look at to work out what to return to the caller. And so by passing in this canister ID, that is the hack canister, as can be seen. If you look in Dfx local canister IDs, you can see hack has been deployed to RR blah, blah, blah. Okay, so we've just deployed the default Rust canister to a locally running internet computer instance. So let's delete everything now because we don't care about that stuff. We're going to build some new functionality. So the first thing you want to do is you want to import the CDK and you want to import the macros. And let's just import all of them. And if you see in the cargo toml, which is where you specify your dependencies, it's already provided you with Candid, the CDK, and the CDK macros. And the macros are used to expose functionality to the outside world. So as you build just normal Rust functions, those aren't exposed to the outside world, as in your canister has code that's internal, and then it has its public API that other canisters can call into or people can call into through DFX. And in order to mark a method as being public, you need to use the CDK macros to either mark them as a query if it's just a read-only call, or you can use an update. So let's first do a query which will return a count. So let's call it count, and this returns just an integer. Now, with the Rust CDK, we're going to want to have some data that's held in memory between calls to these various functions. And what you can do is you can use the CDK. It has this storage API. Why do I not have any IntelliSense? I know. Let's just do that. Okay, this should be a bit better now. The reason for that is CLion seems to only like it if the cargo toml is in the root directory that you've opened. Otherwise, the IntelliSense seems to not work. Anyway, let's see if this is working now. So, okay, it will once this bit down here finishes loading. But it's CDK storage, and then I'm not actually sure what it is, so I need the IntelliSense. Here we go. So get, and then what this does is this will return to you an instance of, actually, let me finish it off. I'll kind of build this and then explain what I've done. So in here, we want to define what our state will look like. And when you use this CDK storage get, what it does is based on the type we specify here, it will return to you the instance of that type that is stored in memory, or if there isn't one, then it will create one using the default value. What I mean by that is, say we want to increment this counter a few times, we need to store that somewhere between all of the calls. And so what we would say is we would say get the state and then increment the count. And then when we get the count, it would return the same instance of that state object. So you can actually use this CDK storage get with various different types, and internally it stores the types just in a dictionary so that each type has its own object. So in our instance, we just want to say state.count, and that will return whatever the current count is here. So I can try and build that. Oh yeah. So I need to put on here the default trait, and that is because in order to use CDK storage get, whatever it is that you're returning has to implement the default trait, because if there isn't an instance currently stored in memory, it will create one using the default value. So you can either just derive the default value, or you could implement the default value yourself. In this instance, by just saying derive default, it will create an instance and the count will be 0. Okay, so now what we want to do is we want to be able to update that count. So same as the Motoko version. Oh, no, sorry, that's wrong. This should be get count. And then count, what this did is this would increment the count by 1 and then return the new value. So in this case, we want to get the state again, as before, but this time we want a mutable reference, because in this instance, we're going to be updating the state. So this will return a reference to that same object that we got here, but this time it's a mutable reference, which means we'd be allowed to change it. So we can say state.count plus equals 1. That will increment it by 1. And then we just return state.count. So let's just try building. Okay, that looks good. And we can do a Dfx Deploy hack just to deploy the one canister. Okay, Dfx start. I must have closed it when I closed the previous instance of CLion. Dfx start. I should have done that in a new terminal tab, really, but okay. So now we can do a Dfx deploy. And that is done. So now we can call into these two methods, get count and count. So we can call into dfx canister call hack. That's the name of the canister. And in fact, when you're first using these commands, you should just use help to be able to see what the different options are. So we're going to be using this one, call. And what that means is we're just calling a method on the canister. So dfx canister call, and then the canister name, and then you put the method name. So let's do get count, and then the args, which in our case is just empty. So that returns 0. So now what we can do is we can try calling count. 1, 2. Okay, and then if we call get count, that returns 3. So you'll see get count was actually quite slow there, whereas when Carsten was doing it, it was really quick. And that's because you need to specify in your candid file what your interface looks like. With candid, this happens automatically, but with Rust, the tooling isn't quite as good yet, but it will be in the future. But for now, you need to manually specify what your interface looks like. So in our case, we have get count, and this takes nothing, and it returns a nat32. It returns in Rust a u32, but the equivalent type in candid is a nat32. And then we've got another method called count, which again takes nothing and again returns a nat32, but this time it's not a query. So you don't need to say anything when it's an update, but when you want it to be a query, you need to specifically say query. So now, if I do get count again, you see it's really quick. So let's implement another method. And this time, let's call it reset. And that doesn't need to return anything because when you reset, it will just be 0. So in this case, we want a mutable reference again because we're going to be modifying the state. And what we can do is just say standard mem take state. And what this does is it will just, this state is a mutable reference to the actual object itself. And what this function does is it says, take the object at that reference and replace it with the default. And so when we replace it with the default, the count will just go back to 0. So we can do a Dfx deploy again. And so one thing to note here, though, is before we did the deploy, the count was 3. But now, after we've done the deploy, the count is back to 0. And that's because we're not actually saving a state between the upgrades. So let's just make sure that reset function works. So we can call count. Let's do it one more time. So the count is now 2. And then where's reset? Oh, I haven't called it before. So now if I call reset, we get nothing back. But now when we call get count, the count is 0. Okay, so that reset looks like it's working. So now what we want to do is we want to be able to do upgrades to this canister, but maintain state between those upgrades. So the way to do that is to use what's called the pre-upgrade and post-upgrade functions. So pre-upgrade runs, as the name suggests, just before an upgrade happens. And what you want to do in the pre-upgrade is move all of your objects from the heap and serialize them and then store them in the stable memory. Stable memory lives outside the canister in the replica. And so when the canister's process is shut down and the heap is wiped, and then the upgrade happens, the new process that the canister runs can then pull the data out of the stable memory and deserialize all those objects back into the heap again. Hopefully that made sense. So in pre-upgrade, what you want to do is you want to call into the CDK again. The CDK tries to make it as easy as it can for all of this. So IC CDK storage, stable save. And what you pass into here is the object that you want to save into stable memory. And it has to be an object that is serializable using candid, because this stable save function, it serializes using candid. You see here, it does this candid write args. So what that means is you pass in a Rust object, and then internally in this stable save, it will serialize that object to bytes using candid, and then it will save those bytes in stable memory. So in our case, we need to grab the state out. Like so. And then we need to pass it into this stable save. It'll probably look a bit weird how I've done this with the open bracket, then state, then a comma, then close bracket. The reason for that is that candid serialization and deserialization is only implemented for tuples. And this syntax is how you specify a tuple with a single value. You could pass in multiple values in here. So in fact, we could have state, 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 and that would then serialize a tuple with 3 items, which you would then need to deserialize onto a tuple with those 3 items. So yeah, pre-upgrade is now done. So what this is going to do is it will grab the values from memory and then serialize them into stable memory. So it will grab the value from the heap and then save it into stable memory. And then in post-upgrade, this is what runs after the WASM has been upgraded, after the canister has been upgraded to the new WASM. In here, what we want to do is we want to retrieve that data from stable memory and deserialize it back into the normal Rust objects. So how you do that is you say IC CDK storage stable restore. We can just do an unwrap, and that will return to us the state. So we now have the state as it was when we saved it into stable memory, but we now need to put that back. We need to save this somewhere so that it can be used by the app on subsequent calls to these methods. So how you do that is you say IC CDK storage get mute equals state. Now what this has done is we've got a reference to where this where the state value will live, and then we dereference that and set the value to be the state as we want it. Essentially, this get mute is pointing to where the state will live. And so we say where this reference points to, set that value to be the state that we just deserialized from stable memory. So now we can try doing a deploy. Oh, something was wrong. Okay, yeah. This type needs to implement candid type, and also deserialize. That's because it uses candid to do the serialization, and then it needs this surd deserialize attribute in order to do the deserialization. So that also means that we need to import those. And I don't think surd is included. It's not. So let's try that again. Something's not right. Ah, yes. In here, we need to do the same tuple little play around that we did when serializing. So we need to do the restore onto a tuple with a single value. And what you can do is you can just deconstruct that like this. And by doing it like this, it means that although this left-hand side as a whole is a tuple with a single value, the state variable is the tuple with a single value is deconstructed so that the state value is only the single state or of the state type rather than being a tuple. It's just a simpler way of doing it than the other way would be like that. And then this is a tuple. And then in here, you'd need to say .0. That working? Anyway, yeah, so it's nicer to just deconstruct it here. So let's try doing that deploy again. Oh, what was that? Stable save. Yeah, okay. I should do unwrap on there because that can throw an error. Okay, and so this didn't work. And you see here, the error message is saying it's coming from line 13, and that's here. And this is because we're running this post upgrade and it's trying to deserialize the data, but we never ran pre-upgrade in the version that's already deployed. So what we need to do is we need to just comment this out. That's now worked. And then let's put it back in. And what that means is on this next deployment, it will run pre-upgrade first and then post-upgrade. And so now it should work. Okay, cool. So let's test that out. So if we call count a few times, so the count is now 3, and then we do a deploy. And then if we call get count, count is still 3. So it's preserved that data between the upgrades. And so you could add more functionality here. You could add, whatever, and then do a deployment. And your new version of the canister will contain your new functionality, but it will still have the data from the previously running version. Yeah, so I think that's pretty much all I intended on covering. There are some things you need to look out for if you're using this method of storing state between functions, and you're using the ICCDK storage get and the ICCDK storage get mute methods. They can be a little bit dangerous. The SDK team, I think they're working on having a safer way of using state, because if I do this, let state 2 also a mutable reference to state, and then if I just copy that, the Rust compiler will treat these as being 2 mutable references to 2 different values, but they're actually not. These 2 are actually pointing to exactly the same thing. And it's because within here, within get mute, it's actually using some unsafe code. So it's completely fine if your app is very basic. It's just, just as a hackathon app. But if you want to do something that's a more long-term project, I'd recommend actually avoiding using this just to stay on the safe side. There are some other videos that DFINITY have uploaded for building canisters in Rust that I actually did some of those talks, which were longer. And so I went into how to do it more safely. But I think just for the hackathon, it's completely fine to just use this method. It's easier. But yeah, if you're doing a project that's going to be more long-term, more of a serious project, I'd recommend avoiding this, really. Okay, I could show deploying onto the IC, or unless Carsten, did you?
No, I think
we've
it's,
got what, 20 minutes, or
yeah,
should we do?
Yeah, I would say let's have a stop around 15 so we can read some of the questions. We have a little bit of questions, so yeah, if you have like other 10 minutes.
Yeah, okay.
If you want.
I guess I can show, because for now I've only been deploying this to the canister running locally. So what I can do is I could deploy this to a canister running on the actual internet computer, as opposed to the one, a fake one I've got running locally. So to do that, what you can do is you can run the command dfx ledger, what was it? Account ID. Well, in fact, first we can see the balance. I'm pretty sure my balance is 0. We need to run this on the real internet computer. Okay, so my balance is 0. So in order to create a canister on the internet computer, you need to pay the canister initialization, the canister creation cost, and also you need to initialize that canister with some cycles. So you need a small amount of ICP to when you create the canister. So let's do that. So dfx ledger account ID. So this is my account ID. And then I need to send some ICP to that account ID. Okay, so I've got some here. So I can send to that address, and let's send 0.1. How much is that? 1, yeah, 0.1. Hopefully I got that address right. CCB, yeah. Yeah, that looks right. Okay, so now if I do balance, yeah, so I've got my 0.1 ICP. So now what you can do is dfx ledger, let's just see what it was again, create canister. So dfx ledger create canister, and then specify the controller of the new canister. So we need to find out our controller, our principal, I mean. So identity get principal. So this is the principal that we are currently using when sending requests through DFX. And so because we want to deploy to this canister through DFX, we need the controller of that canister to match the principal that our DFX commands are sent with. So we do dfx ledger create canister, and then options. So amount would be 0. It would be 0.1, but you actually have to pay 2 transaction fees to create a canister. So let's say 0.998. I think I've got that right. And then the controller is this. I haven't got that right. I need to specify network IC. Let's go. Yeah, so you'll see this, the transfer is already sent but then you have to wait a bit longer for the canister to be created, because you essentially send the ICP to this canister called the cycles minting canister. And then you tell the cycles minting canister, I've sent you some cycles, I've sent you some ICP, I want a canister back. And the cycles minting canister will create you the canister. So what we can do now is copy the canister ID's JSON. And then we can put the canister we've just created in here. We don't need any of these other ones. And we need to change that from being local to being IC. So now if we do a Dfx deploy network IC hack no wallet. The reason I'm saying no wallet is, oh, actually, I'm not sure I need to say no wallet anymore. I think in the later DFX versions, you don't need to. But previously, all of the DFX commands would go via a wallet, but then we wouldn't be able to install because only the principal, who is the controller of the canister, can install code on that canister. And creating wallet, that's exactly what we wanted to avoid. Essentially, the command needs to come straight from my DFX principal because that is the controller of the canister. All right, so that's it. So this is now installed. I don't know what's going wrong there. I think this is trying to use Candid UI, and I think you need to do something. I can't remember exactly how you do it to get the Candid UI to work with Rust canisters, but we can still call into that canister. So we can say DFX canister network IC call hack count. Is this going to work? Yes, cool, good. So this is now running on the internet computer. And so, yeah, this canister is now accessible by anyone. Okay, yeah, I think that's pretty much all that I wanted to cover. Should we go through some of the questions?
Yeah, I think so. First, I would like to thank you both, you and Carsten, for those two run through. Really well done. I think a lot of people in the chat and a lot of people have questions. So yeah, there was a lot of commotion. So I will start maybe going through the questions from the beginning. Maybe some things refer to more you, Carsten, now. We have a more general question. Is how to learn Motoko if I have no background in coding. I know coding in general, it's pretty hard. Do you think there is a high barrier in entering in learning Motoko, or do you think it's quite easy to start?
I think it's fairly easy. One good thing about Motogo is that there is a ton of examples of how to develop dapps on the IC in Motogo. We have, if you go to GitHub /DFINITY/examples, there are a ton of Motogo examples, and I think they're great to learn from. We provide a lot more Motogo documentation than we provide Rust documentation. So if you go to smartcontracts.org and go to our documentation there, I think there's a lot of useful information for all levels. If you're getting started, there's a lot of information describing how it works, the basic concepts, and how to get started. So I would say between the documentation and the many code samples there are, I think that's a good starting point. I would also recommend if you get stuck, if you try it out and get stuck, go to forum.dfinity.org. There's a ton of developers, and a lot of them are using Motogo that really great at helping you to overcome any barriers you may have. For me, I've been developing in a lot of different frameworks and programming languages before, and mostly JavaScript the last few years, and I think that there are a lot of similarities in the syntax. So for me, it doesn't feel completely unknown. There's definitely an element of understanding the syntax, even though I was new to it when I joined the company. So I don't think it's too hard, and there are a lot of resources that can help you if you wanna try Motogo. But otherwise, Rust is also available. If you have past Rust experience, that might be a quicker way to get going.
Yeah, just to add to that, I think if you have Rust experience, go the Rust route. But I think if you don't, it's just so much easier and quicker to get started if you use Motoko. So yeah, I'd really recommend it if you're just building something for the hackathon, especially. I think just it'll save you a lot of time if you just use Motoko. Even though I was the one pushing the Rust example, I think it would probably benefit most people to use Motoko.
Yeah, we need to advocate for both, right? A little bit for Motogo and a little bit for Rust. Our next question is, what's the process for updating data structures of stable variables?
So I actually have for table variables.
Yeah, I think it was like around the beginning when it started running through like how to start with Motoko and things like that. So yeah, it's I don't know especially what this refers to. If Jesse, you're still in the attendees, if you want to write down a little bit more of context in your question.
Yeah. I did see there was a question about stable variables. I don't. It was not about that, was it? Because I do have a little bit of information about that.
Yeah, there was someone in the chat actually asking a little bit more regarding stable variable. If I get there, let me see.
I can share my screen and just go through. Like,
yeah, I think it would be helpful.
Yeah, it's just a couple of slides. I'm not going to do it with code, but I think the demonstration in the slides are. Let's see. Okay. Because it is a little bit different, but still similar. So in Motogo, we kind of distinct between the more simple types of variables like text or numbers, and then the more complex like a hash map, and we do need to treat them a little bit differently in Motogo. The very simple type in this is from a counter example. If you add stable in front of when you define the variable, then it will become a stable variable, and it will do the same as Hamish showed, that it will persist even after you do an upgrade of your code. The next one here is a little bit more complex. It's using a hash map to store the data, and it's actually doing exactly the same as in Rust, where we have a pre-upgrade and we have a post-upgrade function that is called on upgrades, and here it's the same. We serialize the data before we upgrade and deserialize it after we upgrade. And if you see at the top here, what we do is we have a simple array that we initialize as a stable variable, and then in our code we work with the hash map, and the hash map on load of this code, we populate the hash map with the data from the entries array, and then we can do other operations, everything we want to do with our hash map in our functions here in the register and the lookup, just work with hash maps as we all otherwise would. But as said, when we do the pre-upgrade, we serialize the data, and the same when we load this up again, we populate the hash map with the data from the array. So it's very similar, but it is a little bit different. And then if it's just a simple text or like a number in this case, you actually don't need to do the pre and post upgrade. But as you build more and more complex applications, you'll probably have a combination of both, and then you can handle it with the pre and post upgrade functions. So yeah, that was just a quick run through of how it works in Motogo. Very similar, but just a little bit different. And this is well described in our documentation as well. If you get into working with this in your project.
Thank you so much. I will jump a little bit between the questions, just not to forget like the people that have written them last. Fabio asks, so you need to log into DFX in order to create canister and upgrade them, or they are in separate accounts? In that case, what are the best practices to keep the keys for deploying canisters safe?
Yeah, when you create a DFX identity, a corresponding PEM file with your private key is created. And if you want to back up, to keep your account safe, you'd need to back up that private key file. You can find it in, I think it's on my machine anyway. You can go to, is it .dfx config? I'm not quite sure where it is actually, but when you create each time you create a DFX identity, it generates a new private key. And if you want to ensure that you don't lose access to your canisters, you'd need to back up that private key.
Okay, thanks. Carsten, do you want to add something to this?
No, I don't really have anything to add.
Okay. I will go for Miko's question right now. If data is persisted in memory, how much data can be stored in the memory given the limitation of the machine the DAP is running on?
I think currently each canister can use 4 gig of stable memory. Is that right, Carsten? Do you know?
Upgraded to 8.
I thought it was upgraded to 8 in that you could have 4 gig on the heap and 4 gig in stable. Okay. I'm not sure though. I know there are plans to up that massively. They want to have it so that you could have, maybe even terabyte. To be honest, I'm not sure, but there are plans to make it much higher than it is currently.
Yep.
Okay, thank you so much.
And if you need to store more data, you can spread it over multiple canisters.
Mm.
What are the current supported front-end frameworks for the canisters? Is Vue Next.js supported?
Yes, it is. I have personally used different JavaScript-based frameworks and have not encountered any issues. I know we have, I believe we have some examples of Vue. We have Svelte, we have React.
Yeah, OpenChat uses Svelte.
Yeah,
it's really nice actually. Svelte. I think it's nice.
Yeah.
But there's no reason you couldn't use any.
Yeah.
The front end, the HTML and the JavaScript is just served up from the canister, and then it runs in the browser, and it doesn't run on the internet computer. So you could, in theory, run any front end framework you want. It's just the setup might have to be more manual.
Yeah, I think there was like a question that was quite similar in the sense that JavaScript was used for the front end in the demo. Is Motoko not ideal for the front end?
No, Motoko is a backend language. So you can the way I look at it is we have three parts. We have a backend, and this is where we use Motogo or Rust. We have a front end, and there you typically use some kind of JavaScript-based framework or whatever, plain HTML and JavaScript, but whatever you feel comfortable with and use. And then we have Candid, who ties it together and creates an interface between the two, and exposes the backend also to the rest of the world and to other canisters. You can do inter-canister operations as well. So we expose the backend through Candid, but yeah, it's the backend canister is running Motoko, and we do that in the front end.
Okay, thank you. There is a question by Will, who is quite long, so I'm gonna ask you to help me read it. So he's saying he's been trying to implement a loading bar using JS embedded in the index.html file. And after creating the element called script, I'm using script.unload to update the loading progress, but it doesn't seem to work. Maybe can you help with a suggestion or advice for Will in this case? If you need me to copy paste the question or.
Yeah, I don't know about this one. I don't really do much front end stuff.
So if the front end is okay, I'll just see.
Oh, he says, I think it's answered already. As you said, it is served as normal.
Okay.
Yeah.
Thank you so much, Will. I didn't realize. So yeah, I would say we have quite a few questions, but our time is up. And I think like what can happen is that obviously comment to follow up under the YouTube video, or as Carsten said, there are a lot of like resources from old videos of like a community conversation, or from the forum of developers of DFINITY, where you can find people to help you out, also in your region, in your time zone. So that could be really useful. There are a lot of resources also going out from the wiki of the Internet Computer and also smartcontract.org. So we tend to recommend to use those resources because they could be like lifesaver for the hackathon. Carsten, Hamish, anything you want to say to close this first workshop?
No.
No, I'll just encourage everyone to start playing around with it. It's really fun, and it's there's a lot of resources. I already mentioned smartcontracts.org, our documentation site. We have the forum, the dfinity.org. It's a great place to ask questions if you get stuck, or if you want to learn from others, because if you run into something, someone else has probably experienced that before. And we also have a very popular Discord channel as well. So there should be plenty of resources out there.
Actually, I have just seen Fabio wrote a question, which I think is quite important because it's different on the Internet Computer versus a lot of other cryptos. He says, do we need a get count since the variables are private by default in canisters? And yes, in the internal state of canisters is private. Only what the canister exposes to the outside world is public, which is different to things like Ethereum, where everything is just public.
Okay, thank you so much, Hamish, for this. I haven't noticed that, but yeah, thank you lots to everyone. I will close the call now, and yeah, thank you so much for your participation. I hope you had all your answer, and we will see each other soon at the next webinar. Okay, bye everyone. Have a nice evening, afternoon, morning, whatever is your time zone.